Hello students, welcome to Organic Chemboard's YouTube channel. In this video, I am going to teach you how to solve the given examples. These two examples are for preparation of alkene molecules. Let's get started with the first question. It is a reaction of a dicarboxylic acid. What is dicarboxylic acid? Molecule with 2 COOH group, like this. First, it is treated with KOH. We know that whenever an acid reacts with base like potassium hydroxide, it's going to form a salt, potassium salt of the carboxylate ion. This is a simple acid-base reaction. Now, this upon electrolysis. Remember, this electrolysis is also called as Cobb's electrolysis, where we are going to get free radicals. That means there is a decarboxylation and then we are going to get a free radical. The free radicals are the reaction intermediates which are formed during the course of the reaction, and they are highly reactive. And also you can see there is a carbon-carbon single bond. There will be free rotation. Therefore, there is a possibility that it will undergo free rotation and these two methyl groups can go opposite direction. These two free radicals will get neutralized by forming a pi bond like this. Since it is a free radical, I am using fishhook arrows. Fishhook arrows indicate it's a free radical mechanism. Now, look at the stereochemistry of the products. This is a cis molecule and this is a trans molecule, and we are going to get both the products in the given reaction. Therefore, product B and C are cis and trans alkene molecules, butene molecule. And what is the relation between them? They are geometrical isomers. Therefore, the right option is option A. Moving on to the next question. In the given reaction, what is the product P? First, identify what is the reactant molecule. The reactant molecule is an ester because of the functional group COO. When we have an ester and when we heat it without any reagents, without any solvents, we call this as pyrolysis. And since the molecule is undergoing elimination, we can call this as pyrolytic elimination. How to write the reactant? Observe carefully. I am going to write the molecule slightly different than what is given here, so that predicting the product would be easier. Now, the ester is rearranged in such a way that it will undergo a cyclic transitional phase elimination. What exactly it means? Oxygen is electronegative element. Because of that, it starts interacting with the hydrogen present here, which is electropositive. So due to this, what happens? This bond will become weak and it will be shifted to carbon and carbon. This carbon cannot be pentavalent. So what it does? It will undergo elimination. It will break the bond. Now, what product are we going to write now based on the arrows used? Remember children, why we write arrows? Because it shows, it will predict what is the product formed in the reaction. It will be easy for us to predict the product. Now, this is our product, that is 1-butene molecule. What about the byproduct? The byproduct is acetic acid. Since it's just a byproduct, it is not given here in the reaction, right? So the major product, the main product is 1-butene. Therefore, the right option is option A. Now, the additional information I am giving to you here is why it is not 2-butene. Because when we do elimination, there is a probability that you might get 1-butene or 2-butene. But why not 2-butene in this case? Remember, in pyrolytic elimination of esters, the least or the less stable alkene will be formed. The reason is due to steric hindrance. Steric hindrance. In pyrolytic elimination, the reactant is in the gaseous state. That means the concentration is more. When it is so, the steric hindrance plays an important role. You can see here, ethyl is a bulkier group as compared to the methyl. Therefore, the hydrogen is picked from the carbon with the more number of hydrogens. Therefore, you are going to get one butene as a major product. Thank you for watching this video.